Well, thanks for having me. The first thing I want to say before we get started, this is the best organized event I've ever been to. These guys are doing such an amazing job. We're here like for 2 days already. We've had an excursion to the mountain. It's amazing, really, really amazing. I'm so glad to be here. So yeah, this is me. I'm Daniel. I'm into cloud native. I'm a consultant. I work usually with big customers in Germany, banks and regulated environment, hence the talk. I like my cat, I like metal music, and I like doing sports. And I'm going to cope with one of the big questions of life today. Are you compliant? And I think this especially resonates with Switzerland, since I think if I did this talk in Austria, not 100 people would be here today. So thanks for showing up. All right, so if we talk about compliance, I think the first thing we need to talk about is the word, what does compliance actually mean? And in the more specific sense of the word itself, compliance actually means adhering to some applicable specification. In the IT world, we always think about, if you think about compliance, we think about security, 95% of the time. But just to give you an idea that compliance from a business perspective, from an organization perspective, it pretty much just means to be compliant with some specification that usually comes from outside the organizations, or that might also be coming from within the organization. So compliance doesn't always have to be related with security, although for the rest of this talk we're going to focus on that topic, especially on things like ISO 27000, so Information Security Management System compliance, PCI DSS, which we're going to hear about later, which is the payment card industry data security standard, or TSAX, which is a compliance framework pretty similar to ISO 27000, especially for automotive industry in the DACH region. But compliance is not only concerned with security, but for example also with other things, for example with quality management. I think pretty everybody knows about the famous ISO 9001 certification for quality management systems, which is especially interesting in manufacturing companies producing goods, also for streamlined organization like in automotive industry, but also in IT, of course. There are things, for example, like the ISO 25010, which is concerned with the quality measurement, standardized quality measurement of software systems. So this is definitely something I can recommend. It's nothing that you can get certified against, but it's something you should probably know to get a formalized view on how to assess the quality of software systems in a broader picture. EFQM is a quality management system also concerned with the quality management process, and this is actually something that you can get certified at, again, also specified mostly at automotive industry, but can also be applicable to other industries as well. And just to give an example on other compliance things that might be relevant also for IT in the upcoming years, we have, for example, environmental concerns. For example, ISO 14K, so this whole family, is concerned with environmental management systems. So how do you reduce waste? How do you, for example, when we're talking about greenhouse gas, how do you measure and report greenhouse gas exhaustion as a company? There are also standards for that you can be compliant against. So just to give you an idea, especially this topic will also be relevant in terms of cloud computing, CO2 emissions for big AI farms, also in IT. Kepler project, for example, this is something that already deals with this kind of concerns. But today, we are especially focused on compliance in IT and with a focus on IT security in particular. All right, so one of the big questions is, why does it matter to be compliant? To tackle these questions, I like to have kind of two viewpoints. We have an outside view, which is, for example, a legal obligation. Pretty much everybody, I think, has heard of the Cyber Resilience Act, since this is one of the big buzzwords. But think older or broader, for example, GDPR in Europe, DSGVO. This is something you just have to be compliant with. There's no way around it. On the other hand, an outside view might be a competitive advantage, reputation. For example, if you want to work in the automotive industry in Germany, you have to be TSAX compliant, full stop. Otherwise, they just won't work with you. It's a prerequisite. And to give an example, we have like an excerpt of legislation here. You don't need to read anything. The important part is this. This is from DSGVO, GDPR in Austria. it says you need to ensure to have proper technical and organization measures, and you somehow need to be able to prove it, that you operate or that you process data in a somewhat proper way. It doesn't say how you're going to achieve that or what it actually, how this should be implemented, but this is pretty much the first hierarchical level when we talk about compliance. It's the law. It states what should be achieved, but not how you do it. From the inside view, the incentive is pretty much to just improve system quality. So adhering to certain compliance frameworks and standards actually means that somebody has an idea of how things should be operated, and this usually refers to some kind of best practice. So in the broader sense, this helps you as a company and organization to improve system quality, performance, transparency, or in our particular case, security. And usually the controls that we think about when we think about these frameworks are either on a process or organizational level, or they're concerned with technical best practices and technical requirements. So we're going to see this in a minute, that these are pretty much the big distinction parts. If you take anything from this talk, it's pretty much these two things. The left-hand side is actually quite tough to evaluate, especially in an automated way. The right-hand side is, at least it's feasible. It's not easy, but it's manageable to some degree. So if we talk about the hierarchy of compliance frameworks and controls, there is a certain ladder to it. The highest thing that we have are regulations, laws, external obligations by your industries, so things that are kind of vague, but they're non-discussable, so you need to apply to these. The next level underneath we have are policies. These are usually some high-level collection of requirements. Most of the time, they are already kind of industry-specific. So policies might not apply to every organization or company or business unit, but they are already like in some kind of niche. The next level are standards, which are semi-specific implementation best practices. They are definitely industry-wide. Think about best practices on a very simple example, how to configure an Exchange server. This is nothing like no intellectual property of a certain company, but an industry best practice, a standard. Then we have guidelines. Guidelines are pretty much implementation procedures. 9 out of 10 times, they are already internal because they are system-specific and organization-specific. This is pretty much your checklist on how to implement a standard. And the last thing that we have are controls. These are specific technical, usually technical implementations and instructions on how to get certain points, certain controls done. We're going to see this in a minute. So controls are usually very entangled, for example, with CIS benchmarks. I think most of you have already heard about CIS benchmarks. We're going to see that in a second as well. So just to keep in mind, we have this hierarchy of very high-level formulations, high-level documents that might apply to everybody, down to the very specific system, very specific technical controls that are going to be implemented. All right. To give an example, we already have seen about the law. So this is GDPR, DSGVO. GDPR, for example, says that each person, with regards to their personal data, has the right of correction, deletion of not appropriately processed data. It doesn't say how a company has to achieve that, how this works, but you need to be compliant with that. So if you're processing personal data as a company, you need to ensure some way or another for a person to contact you and to correct data or to delete data. If you think about a policy, so one level below, there is, for example, this famous NIST cybersecurity framework. Raise of hands, who has heard about NIST CSF? Okay. NIST publishes like, I don't know, 25, 30-ish of these frameworks, but this is pretty much the high-level document. This is already concerned very particularly with IT systems, IT security. And here, for example, it says that these controls are concerned with identity and access management. For example, users, services, and hardware need to be authenticated. It also doesn't say how you're going to achieve that, but this is a prerequisite that we already can check against, that we can audit. One of the most famous standards, especially in the DACH region in Germany, is ISO 27K. The German Department for Information Security published a BSI Grundschutz Compendium, which is kind of a free version and documentation of ISO 27K requirements and best practices on how to be compliant. And we already see that this is kind of an established standard, which is already more in detail, and it actually prescribes some kind of a best practice on how to configure and how to maintain certain parts of a system. So for example, it says persistence of protocol data, of log files for containers. They must be stored outside of the container, at least on the host, best case in some sort of centralized logging system. So this is even more particular. This is a standard on how to do configuration in a proper sense. Another standard that I actually can refer to everybody here is PCI DSS. This is a payment card industry data security standard, which, as it says, it provides a baseline of technical and operational requirements, especially designed to protect account data. So this is very specific in terms of industry. This only applies to companies that process credit card data that are involved with payment credit card transactions and also with credit card user authorization and authentication data. And they actually created a quite good standard from my personal point of view because it's understandable. The document is readable. It's not like these lawyer English thing that we see in some of GDPR and laws, but this is actually tangible. This is something that you can act upon. And this also, and we're going to see that in a second as well, this already prescribes ways of how you can test against certain criteria, how you can assess them, how you should implement them. Everything structured together in one nice document, so this is something that you can definitely have a look at. Spoiler at this point, all these policies in one way or another always refer to the same points, so there is no big deviation. If you're ISO 27000 compliant, you're pretty much doing great in terms of PCI, so there's a big overlap through all these documents. Also, the same is true for Cyber Resilience Act. If you're compliant with one of those, there is a high chance that you also do great with regards to another certification. All right. The last level that we have, when it really comes down to technical controls, the gold standard here are the CIS benchmarks, so the Center for Internet Security. They release benchmarks tailored to particular IT systems, even down to particular versions. And they are very, very concrete formulations on how you should configure something. So this is exclusively concerned with configuration. This is no coding best practice or anything, but this really tells you, for example, how to configure a Kube API server and what not to do. How you're going to assess it, how you're going to audit it, how you're going to remediate it. So this is very, very particular, and this is something that most of these compliance automation tools are usually jumping on, because this is something that's technically tangible. All right, so to answer the question, are you compliant and how can you figure it out? This is usually like a decision tree process. The first thing that you need to ask yourself, well, what do I actually want to be compliant with or need to be compliant with? So you need to decide on some kind of policy or framework. The next thing is, who is actually able to attest if you're compliant? I mean, of course, I can say that we as full stacks, we are ISO 27 and ISO 9000 compliant. If I'm going to tell you, well, you either have to trust me or you have to trust an external auditor that actually has some kind of document that proves that we are compliant and that there has to be some kind of assessment and evaluation process behind that. So the question is, how would an organization actually prove if you're compliant towards a certain framework? And I hate to break it to you, it still is documentation, interviews, assessing processes and logs. So although there are companies that are claiming compliance can be automated, yes, to a certain degree. The question is, how do we actually generate this documentation and the results that an auditor will see so that we are actually faster with proving that we are compliant? And this is where these processes, docs, and also some tools come into play. All right, so to reiterate on that, scope is pretty much everything if you want to be compliant. It's also one of the first things that we see with PCI DSS. It states very clearly on which systems are actually concerned with the certification and which system need to be evaluated and assessed. So we have this hierarchy from law, from our stakeholders, down to organization, down to the applicable framework, policies, and standards. And then we have these two distinct categories of non-technical requirements and technical requirements. And for technical requirements, those that are particularly concerned with, let's say, our system, if you're a platform engineer, let's say operating systems, Kubernetes, web servers, whatever. And at the very bottom, we can see that we actually have two kinds of technical requirements in our system that we can check, which are manual checks and automated checks. Automated checks, for example, is to evaluate the command line arguments that a process is started with. Think Kube API server. Manual checks are just things where there's no feasible or practical way to test them in an automated way, so you still need to log in and check yourself. And this is pretty much true to this day. There is no all-around global automation available yet, unfortunately. All right, so I'm going to show you two examples of two kinds of frameworks. The first is PCI DSS, which again is a semi-specific framework that is regarded with multiple systems. There are different assessing and testing methods. Gosh. And this heavily relies on docs and on procedures. On the other hand, we're going to see syscontrols, which are very specific to the point. For single systems, for single versions, there are fixed testing procedures available, and they are concerned with very, very defined configurations at the end of the day. So, for PCI DSS, as already said, the first thing we need to think about is scope. What is actually interesting for us if you want to be compliant with something? And for PCI DSS, it's actually quite simple. That's literally the first page in the document. It's intended for all entities that store, process, or transmit cardholder data, CHD, and that are concerned with authentication data. So whenever you enter your PIN or something, that's already also concerned. And system components actually means all people, processes, and technical systems that are somehow involved or that may potentially have impact on the security and stability of this thing. So to boil that down a little bit, if you're running a pod on Kubernetes on an operating system in a network that somehow processes cardholder data, this is definitely in scope. If you have a parallel system that does, I don't know, mailing and has no direct contact and no impact, then this is out of scope. If you want to actually be certified against PCI DSS, at some point or another, you will have an auditor come in and assess your standards. So we've already seen before this little excerpt of the requirements, and the methods that they are going to apply are either examining, so this really means having a look at the configuration files, at the audit logs. This is usually where all these things as code come in handy. So if you have GitOps, if you have infrastructure as code, if you have configuration, best practices, and policies, this is the thing where they are going to help you to improve and to be faster in the audit process, but still somebody needs to look at it. The second testing method is observing. So they are pretty much having a look how somebody or some system is doing a certain task. Argo CD is restarting a pod due to some event. Some engineer is deploying a new release version according to a specified process, something like that. And the last thing that they're going to do, they're going to interview your employees or yourself. So they're actually going to check if processes are actually lived and if people are informed and have the know-how about how things are done with regards to this particular system that needs to be certified. So to boil it down, examination, this is where automation comes in handy. All the other parts, yes, to some degree, but there is still manual effort, and probably a lot of manual effort. If you have an auditor in-house, and this is pretty much what they're going to do, this is this reporting template that they're going to use. And as you can see, for example, here we have a point that says establish and implement firewall and router configurations according to some configuration standards. They are concerned with documentation and verifying these standards, that they're implemented, and they are concerned with having a formal process in place. And then there's going to be this assessment criteria, if it's fully implemented or not so much. And they're actually going to use the testing methods that we've seen before to get an idea if this is actually true. if there is a formal process, if it's documented, if it's lived. And again, automation can only help you to some degree. It's also quite interesting. You can also download the reporting and the assessment document that the auditor will use for PCI DSS online. This is not true for all of the compliance frameworks. Some of them are behind a pretty high paywall, ISO documentations, for example. Anyway, now comes the interesting part. When we talk about the technical evaluation of systems, we're talking about controls, and then we are 99% talking about SIS benchmarks. This is the industry standard of configuration best practices and how to assess them. Full stop. SIS benchmarks are prescriptive configuration recommendations. In total, there are 1,253 of them, split across several product families. I'm not going to read the numbers. Just bear in mind, this is not the number of products, but also specific versions. Released, deprecated, and in review. So this is pretty much all of them. But still, it's an impressive number. And again, what we're going to see is controls like this. This is one of the points from the Kubernetes SIS benchmark, particularly concerned with the API server. And this pretty much says, do not have anonymous access to your Kubernetes cluster in a technical way. And the cool thing about that is you can automate that. You can get that information, you can check against this information, you can report that information on one node or on a whole fleet. And to do this, I'm going to demonstrate 3 tools. I think we have some time. The good, the not so bad, and the ugly. The good is Kubebench, the not so bad is CNSpec, which is the new kid on the block, and the old reliable workhorse is OpenSCAP. So Kubebench, just to give you an idea, is backed by Aqua Security. They also make Trivy, so Kubebench is semi-integrated in Trivy already. It's released as Apache 2 and is particularly focused only with Kubernetes. Kubernetes SIS benchmark for different distributions. So this can work with RKE2, with vanilla Kubernetes, with some cloud Kubernetes distributions as well. But this is Kubernetes only. No operating system, nothing in container, just Kubernetes. It has some kind of rudimentary custom query language, so you can also adapt it for your Kubernetes distribution if you like. You can use it either as a Go CLI or as a container or kind of an operator, if you will. And it's particularly purpose-built. This was built for attesting Kubernetes SIS compliance. OpenSCAP, on the other hand, is backed by NIST and by Red Hat. It's an LGPL tool. This is particularly focused on operating systems and apps to some degree, for example, Apache HTTP server, Nginx, stuff like that. But it's mostly focused on operating systems. This is also what's used, for example, by SUSE. So the official SUSE compliance checks are also using OpenSCAP. It's very complex. So this is a querying language, XML-based, which uses all these kinds of files to pretty much formulate one check. And it's terrible. I tried my best, but it's still heavily used because it's quite old and it's kind of an industry-wide project, but it's terrible. The new kid on the block is called CNSpec. It's an open source tool by Mondu, released on the BSL. That's why it's the ugly. So it's not considered that really open source, but anyway. This is quite flexible because it's not only purpose-built for operating systems, but for all things that provide an API or that you can attach via SSH. So I can scan Windows nodes, Linux nodes, Kubernetes, SaaS services like my cloud, my GitLab, whatnot. So this is very flexible. It uses a powerful, yet somewhat simple querying language. It's pretty close to JQ and is written in YAML files. Also Go CLI based on a container. And there are multiple integrations, as already said. So this is, in terms of flexibility, this is probably where you want to go. But again, this is quite new. This is not that widely used. This is very particular. OK, so demo time. So what I did in the morning, I created a kubeadm cluster on Exascale. Anybody know Exascale? This number is way too low. It's a Swiss cloud provider, so look it up. Great guys. Anyway, so I created a Kubernetes cluster up front. And what I'm going to show you is how to check if the cluster, the operating system are compliant to their particular SIS benchmarks. So there's a different benchmark for the operating system, which in that case is Ubuntu 22, and Kubernetes 1.30 something. Okay, so first thing I want to do is I want to look at my cheat sheet. So I hope you can see my screen. Does the font work? Okay, thumbs up. So the first demo is about Kubebench. I'm not going to use the container here, the Kubernetes job. I'm just going to run a container here on the node. So I'm now on the master node. And if I run this thing, oh, damn. Have me be God. Better. So what this thing is actually hopefully going to do, I mounted most of the important folders, read-only into there, etc, var, some Kubernetes config files, etc. And what this thing does is it pretty much checks all the sys benchmark specified file permissions, how the API service run, command arguments, etc. And the important part here is it's going to give me text output. So this is pretty much what you're going to get. Looks something like this. These are some recommendations I get. And here I pretty much see the benchmark ID. So if you look for this number in the Kubernetes benchmark, then you can see the whole big picture. And I'm just going to see, did it work or did it not work? I'm not going to go into any detail of why this is failing or why this is passing. That's actually not important for the point I'm trying to get across. The point here is, this is what you get. Stupid simple. You can just run it as a CLI tool, as a container. It simply works, and it always worked so far. But there is no kind of broader integration. The most thing you can do with this thing is you can alter the checks. You can write additional checks in this YAML-based query language. But this is pretty much what you're stuck with. The next thing that we're going to see is OpenSCAP. What I already did, I installed the libscap package, so the CLI tool, and I downloaded, what you can see here, SSG, which is this spec security guide. This is pretty much the scan policies, if you will. This is a public GitHub repo where pretty much all of the big software vendors contribute and where they write policies and checks in the most ugly XML format you're ever going to see. They actually have dedicated build pipelines to generate these XML files. That's a whole bunch of a Python project. This is the full-blown thing. It works, but if you want to start from scratch, this is going to take you at least a day to get the idea of how these policies are actually being created, not yet how you write them. So this is actually the quite sophisticated stuff. If I run this, you're going to see that I'm evaluating this XCCDF file, which is the policy specification. This refers to an OVAL file, which actually includes the technical checks. I'm doing with time? Yeah, I guess. 15 minutes, yeah. And then I'm going to specify a profile. This is actually the syslevel 1 server profile for Ubuntu, since I'm using the data stream file for Ubuntu 2022. So you actually see where I'm trying to go with here. I need to specify multiple things just to run one check. And this is a common thing. This is not like the exotic kind of check that I want to run. This is the default thing. Anyway, nice. Wrong folder. Yes. So this is actually going to do pretty much the same thing, evaluating all these checks. This is going to take a little more time. This tool can also be executed via SSH, so I can also connect to a different node. So there is a little bit more power in that already. And again, this language and these frameworks are there's more content to it than with Kubebench. So this is not only focused with operating systems, mostly, as most of the configuration of the checks, but not exclusively. So if this thing detects that, for example, I've installed, I don't know, an Apache 2 web server, then there might also be some checks particularly focused on this application, and you can also bring your own checks if you like to. So this is what it will look like, the output, but the cool thing is we're also going to see that we created an HTML file here. So what I did, I specified that the report format, where is it? There it is an HTML. So in contrary to Kubebench, we already have something that we can actually look at and which actually looks somewhat decent. Okay, so let me just get my scp command. And what you're going to get is something like this. This is actually pretty good. So this is something I also like to work with. You can see that the profile we specified here in the very top is this Ubuntu 2022 level 1. So for operating systems, there are level 1 and advanced hardening level 2 policies. But anyway, and you're going to get a nice overview that you can also filter in that, get more information. So this is actually quite usable, and this is also usable for an auditor to some degree. The downside for this whole thing is that Red Hat pretty much neglected the whole ecosystem. So if you're now going to work with OpenSCAP, there used to be a workbench tool for graphical editing of these things. There used to be like a centralized policy evaluation service. Most of these things are deprecated. There still is a website, but it's just not usable in an enterprise way anymore, unfortunately. This whole thing went into the compliance operator for OpenShift, just to give you an idea. All right, the last thing we're going to see, and I think I'm actually doing quite okay with the time, is cnspec. I already installed the tool on the machine. I think I don't need that. And what I'm going to do here is I'm going to run cnspec with the scan local configuration. I'm going to use incognito, which means don't talk to the SaaS service. And I'm going to specify a policy bundle. Policy bundle is pretty much the same idea that we have with OpenSCAP. Somewhere we need to have the definition of what's actually going to be checked. And the policy bundle we can see here, unfortunately, is a YAML file. So policies in cnspec are YAML files. The thing then is actually going to discover which asset, too fast. Which asset it's actually targeting. So this is discovering that this is a Linux operating system of type Ubuntu, and it's only going to apply the policies specified in the policy file for this type of asset. So you can also have multiple different, for example, a rel, a SUSE, and Ubuntu check in the same policy, but it's only going to apply the ones that actually are applicable to this particular system. The output is pretty much the same. We're going to have the checks that were executed, the failures that we can see, and an overall status at the bottom. There is no HTML output for that yet. They provide some kind of JSON output so that you can also use it in CI/CD pipelines, etc. cnspec, although, is the only tool that I've presented so far that also provides some kind of an enterprise tier, so you can integrate that with a platform as well. That's also the caveat. The policy I applied here is kind of a Linux security best practice thing. So this is not actually a real sys benchmark. You can get the sys benchmark if you pay for the enterprise version. But they also provide some kind of open source policy that are ready to use out of the box, which, for example, is the one that I'm going to test now. So this was just Ubuntu. So just need to see if I'm in the right folder here. Yeah. Please work. So what I'm doing now here is I'm actually scanning via SSH. So this is also one of the nice features of cnspec. They can target multiple systems. I don't have to run actually locally. I can also just do the same thing remote via SSH or via RDP. But I can also target APIs, for example. So this is actually going to check the Kubernetes security standard on an operating system level. So for example, if the files are properly configured, etc. And what I can also do with this tool is I can connect to the cluster. Let's see if this works. Yeah, There we are. And I can use a command to actually attach to the Cube API, so not to the operating system, but the API, and to run certain checks there. Yeah. And here we can see, for example, that it detected multiple different assets, namespaces, services, deployment, and whatnot, and some low findings, I think particularly concerned with the deployments. So this is just a demo cluster, nothing productive. But the point I'm trying to make here is it's way more flexible than the other solutions, also in the open source variant. So this is nothing that you have to pay for. This is ready out of the box. Okay. Nice. All right. So to sum that up, if you want to check the technical part of some of your compliance frameworks, and there is somewhat related to sys benchmarks, you can do that with KubeBench. It's very easy to use. This is just go to the GitHub page, try the tutorial, and it works. It's vendor-backed. It's definitely Kubernetes only. It's fine for nerds because you either need to run it as a job, Kubernetes job, or via the CLI. And there's no like beautiful output in terms of an HTML or something that you can host on a website or something like that. It's adaptable to certain degrees. OpenSCAP has a huge community, so this is not only vendor-backed, but also backed, for example, by the NIST itself. So actually, SCAP, the file definition and the protocols were actually developed by NIST in combination with Red Hat. It's very, very complicated, somewhat powerful. Most of the comparing operators that you can use in the querying language are focused with processes and files, not so much with APIs, for example. So you're somehow limited to what you pretty much would do on an operating system. They provide nice reports, and it's somewhat adaptable. On the last hand, you have CNSpec, which is kind of small, still a new company, small community. It's also vendor-backed, so I'm not going to sugarcoat it. That's definitely there's a vendor behind that, and they're trying to sell an enterprise offering, which works, by the way, but still. It's very powerful due to its flexibility. And this is actually the critical point here. It's usable because it has a nice querying language, and it can target multiple layers of a whole ecosystem. With the other tools, you have to have KubeBench for Kubernetes, you have to have OpenSCAP for operating systems, and if you want to check if, for example, your storage or your SaaS service or your GitHub is compliant, then you need something else. You need a multitude of tools. CNSpec is the only tool that we found so far that can actually cope with multiple targets in the same way. Same language, same commands, same procedure. If you want to have the good policies at your fingertips, for example, sys benchmarks, you probably need to pay for it. Or you can do it yourself. You can also write your query packs and your policies yourself, or you need to go enterprise. So to finish this up, I think good timing. If you want to be compliant, you still need to maintain documentation. There is no way around it. Doesn't matter which kind of framework and certification you're aiming for. Probably 85% of what's going to be evaluated is not the particular configuration, and if you set this parameter to A or B, but how you did it, how the process works, that the process works, if it's documented, if people understand it. For documentation, I can definitely recommend Dox's code. Is anybody doing Dox's code already? There should be more hands up. It's actually quite easy. It integrates quite nicely. It's freakishly cheap. From a tools perspective, probably not so much from the learning curve, but still. But if you do Dox's code, you already have some nice out-of-the-box features, for example, history, IAM controls, versioning, etc. So these are also things that are going to be reviewed. So definitely can recommend that if it's somewhat applicable to your company. Definitely use fitting tools. So if you're serious about this, we've only had a look at the more technical tools. There are also other tools, for example, Sprinto or Vanta, which are more concerned with proving that you already have documentation in place, that you have processes in place. So for the bigger picture, they provide you checklists of what you need to evaluate, where the auditor is going to be pointed at. So if you're really in a big company and if you're working with, let's say, complex systems, bigger systems, then probably give that a look. And if you're talking about the automation side of things, probably give these compliance platforms, for example, like Mondu a look. it will just save you time at the end. And the big caveat is implement your processes and implement best practices. The tools I showed you can only help you with this very, very particular part of implementing and checking best practices, but this is only a small piece of the bigger cake of compliance and of these frameworks. And proper processes and architecture are still key. Docs and metrics, so that you can actually prove that you're living processes and that they're actually well understood. Probably do everything as code, so there's not just infrastructure as code, there's config as code, there's docs as code, there's a lot more as code, policies, for example. And if you think about automation, pretty much the only thing that you can do are those very system and version specific best practices that are specified in the benchmarks. So that's pretty much it. If you need any of the links, there you go. Thanks for your time and thanks for showing up.
There's no sound. Should I use the other mic? Okay.
I can also repeat it if you want.
I have another one. So there's room for questions. Are there any questions for Daniel? Over there.
Thanks for the talk. I was wondering, is OpenSCAP also able to run, is it only running on live systems?
I'm not sure I understand the question.
I mean, can you also apply these scans to an image, not particularly a Docker image?
Yeah.
Or?
There are some kinds of plugins, I would say, add-ons, specifically for images. Yeah, so you can also apply that to container images, but you're still kind of restricted to the operating system part, if you will. So you're not able, as far as I know, to, for example, scan a SaaS service or a cloud or something like that. So it's still focused on files, on processes, on command arguments, stuff like that. But yeah, there's an integration for images.
Thanks for the talk. As far as I understood, the checks are all like after the fact. That means the system is already deployed. Is there any way to like check in the pipeline of like the Kubernetes resources, for example?
There definitely are, yeah. This is usually concerned with infrastructure as code scanning for manifest files, for Terraform, for whatever you pretty much have in that regard. CNSpec is able to do that. OpenSCAP, I don't think so. Kubebench, I'm actually not sure if they can also scan like plain YAML files or descriptive files. But you should definitely do that, yeah. So this is particularly focused on when the system is running. It's a little bit a topic of artifact management that if you just build a VM or a container, run it and check what it does, because some checks are only applied after processes are running, for example. But the broader answer is yes, definitely use those kind of tools in the pipeline if they're applicable. Most like software scanning tools, Aikido, Sneak, checkmarks, however they are called, they build or they provide capabilities, especially for Terraform, for YAML files, for Kubernetes stuff, so for all these infrastructure as code things.
Thank you.
So maybe a last question?
Thanks for the talk. Just an Outlook question. Is there something already, a tool around which already also fixes the violation, which creates a pull request or something?
Yes-ish. I mean, I don't want to advertise AI at all. I'm one of those non-AI guys, but most of the tools, they actually provide remediation suggestions or fixes, if you will, especially in Bash and in Ansible. And that's pretty much something all of them can do to some degree, because they are very, particularly from a technical point of view. Usually there's also a recommended remediation already present in the sys benchmark, so you don't actually need a tool for that. You can also do it yourself. But for example, the OpenSCAP library, for each scan you write, you can also provide a best practice and a fix command and the playbook in Ansible. Same is true for CNSpec, although I think this is also kind of an enterprise feature. For Kubebench, I don't think so. I think they only provide the statement of if it's right or not. But CNSpec and OpenSCAP, they do, yeah.
Thanks.
Okay, so thanks again, Daniel. Another round of applause for Daniel.